Of course.
Hello, Assalamualaikum everyone. My name is Ayana, graphic design wala, and I'm a level 1 student at Jahan School Islamabad campus. So today here with new colony project. So my topic is climate change and about climate shifts. So first of all, my question is, what is climate shifts?
Absolutely. I'd be happy to help with that. Climate shifts refer to significant changes in the average weather patterns over extended periods, typically decades to millions of years. These shifts can be due to natural factors like volcanic eruptions or changes in solar radiation, as well as human activities, such as greenhouse gas emissions. If you'd like, I can dive deeper into the specifics.
Yes, deep answer on it.
Absolutely. So, when we talk about climate shifts, we generally consider both natural and anthropogenic human caused factors. On the natural side, we have things like volcanic eruptions, which can release large amounts of ash and gases into the atmosphere, temporarily cooling the earth. We also have variations in solar energy output and natural cycles like the Milankovitch cycles, which are long term changes in Earth's orbit and tilt that affect climate patterns over tens of thousands of years. On the human cause side, the most significant factor is the emission of greenhouse gases, particularly carbon dioxide and methane. These gases trap heat in the Earth's atmosphere, leading to a warming effect. बिल्कुल अब बेशक बिल्कुल ठीक है अगर आपको मजीद तफसीलात चाहिए हो या कोई और सवाल हो तो मुझे ज़रूर बताइए
Okay, no. So please speak in English. And my next question to you is, what is the difference between weather and climate?
Absolutely. So the key difference between weather and climate is mainly the time scale. Weather refers to the short-term atmospheric conditions in a specific place at a particular time. Things like temperature, humidity, precipitation, and wind over hours or days. Climate, on the other hand, refers to the long-term average of these weather conditions over extended periods, usually 30 years or more for a particular region. In other words, weather is what we experience day to day, while climate is the overall pattern over the long term.
Okay. So my next question to you is, why uh, climate change affect our body?
Great question. Climate change can affect our bodies in several ways. For instance, higher temperatures can lead to heat stress and heat related illnesses like heat exhaustion or heat stroke. Additionally, changes in climate can influence air quality, leading to more respiratory issues from pollutants or allergens. There are also impacts on food and water security, which can indirectly affect nutrition and health. Overall, the effects are quite broad and interconnected.
Yes, more deeply answer.
Absolutely. So, diving deeper, one of the major ways climate change impacts our bodies is through the increased frequency and intensity of heat waves. This can lead to dehydration, heat exhaustion, and heat strokes, especially in vulnerable populations like the elderly, children, or those with pre existing health conditions. Additionally, climate change affects air quality. For example, warmer temperatures can increase the formation of ground level ozone, which can worsen respiratory conditions like asthma and bronchitis. It can also lead to longer pollen seasons, exacerbating allergies and respiratory discomfort. Moreover, climate change can impact food security. Changes in temperature and precipitation patterns can affect crop yields, leading to malnutrition and related health issues. There's also the risk of waterborne diseases and the spread of vector-borne diseases like malaria and dengue as changing climates alter the habitats of insects and pathogens. Overall, the health impacts of climate change are complex and interconnected, affecting everything from cardiovascular and respiratory health to nutrition and infectious diseases.
Okay, nice. So
I'm
more deeply answer on it.
Of course, let's delve even further. When we consider the physiological impacts, climate change can lead to heat related illnesses, not just from extreme heat, but also from the cumulative effects of prolonged heat exposure. This can impact cardiovascular health as the heart has to work harder to cool the body. It can also exacerbate conditions like hypertension. In terms of infectious diseases, warmer temperatures and shifting rainfall patterns can expand the range of vectors like mosquitoes and ticks. This can lead to the spread of diseases such as malaria, dengue, Zika virus, and Lyme disease into regions that previously weren't affected. Another critical area is mental health. Climate change can lead to increased stress, anxiety, and even trauma, especially in communities that face natural disasters like floods, wildfires, or hurricanes. These events can lead to displacement, loss of livelihood, and a sense of uncertainty, all of which impact mental well-being. Finally, there are indirect effects as well. For example, climate change can influence the distribution of food and water resources, leading to malnutrition and compromised immune systems. This can make populations more susceptible to diseases and reduce overall resilience. All in all, the impacts are multifaceted and interconnected, highlighting the importance of both mitigation and adaptation strategies.
Okay, more deeply answer. No, but my next question to you is how do scientists measure global climate shifts? Please long answer on it, okay?
Absolutely. Scientists use a variety of methods and tools to measuring and understand climate shifts over time. One of the primary approaches is the use of climate proxies. These are natural recorders of climate information, such as tree rings, ice cores, sediment layers, and coral reefs. For example, tree ringers can indicate past temperature and moisture levels, while ice cores contain trapped air bubbles that reveal past atmospheric compositions like carbon dioxide and methane levels. Another crucial method is the use of historical climate data. Scientists collect and analyze temperature records, precipitation records, and other meteorological data from weather stations around the world. By looking at long-term trends, they can identify patterns and anomalies. Climate models also play a significant role. These are complex computer simulations that use mathematical equations to replicate the Earth's climate system. These models incorporate data from various sources like ocean temperatures, atmospheric conditions, and land surface changes to predict future climate scenarios and understand past shifts. Paleoclimatology is another field that's vital in this context. By studying ice cores, ocean sediments, and even fossils, scientists can reconstruct climate conditions from millions of years ago. This helps us understand natural climate variability and identify patterns that are not influenced by human activity. Lastly, satellite observations provide comprehensive data about the Earth's climate. Satellites can monitor sea surface temperatures, ice coverage, atmosphere gases, and more, allowing scientists to track changes in real time and validate climate models. In summary, by combining these methods, climate proxies, historical data, advanced models, paleoclimatology, and satellite observations, scientists can create a comprehensive picture of climate shifts and better understand both natural variability and human-induced changes.
Okay, nice. So my next question to you is, what evidence shows that Earth's climate is currently changing?
Great question. There's a wealth of evidence indicating that Earth's climate is currently changing. First and foremost, we have rising global temperatures. For instance, the global average temperature has increased by about 1.1 degrees Celsius since the late 19th century, and the last few decades have been the warmest on record. Another key piece of evidence is the melting of polar ice. The Arctic sea ice has been shrinking rapidly, and we've seen significant ice loss in Greenland and Antarctica. This contributes to rising sea levels, which is another clear indicator. Global expansion of seawater. We also observe more frequent and intense extreme weather events. For example, we've seen an increase in the intensity and frequency of heat waves, more intense hurricanes and heavier rainfall leading to flooding. Additionally, scientists have noted changes in ecosystems. For instance, shifts in the ranges of plants and animals are evident as they move toward the poles or to higher elevations in response to warming temperatures. Coral reefs are also bleaching and declining due to warmer ocean temperatures. In addition, we have direct measurements of atmospheric greenhouse gases. The concentration of carbon dioxide, methane, and other greenhouse gases in the atmosphere has been rising steadily, and this correlates closely with industrial activity. All these pieces of evidence, temperature records, ice melts, sea level rise, extreme weather, ecosystem changes, and greenhouse gas concentrations together paint a clear picture that the Earth's climate is indeed undergoing significant changes.
Okay, more deeply answer.
Absolutely. Let's go even deeper. One of the most compelling lines of evidence comes from paleoclimatology, which shows that current levels of greenhouse gases are unprecedented in at least the past 800,000 years. Ice core data, for instance, reveal that the current carbon dioxide levels are significantly higher than the natural fluctuations observed in previous interglacial periods. We can also look at the changing patterns of the oceans. Ocean heat content has been increasing, and the oceans have absorbed more than 90% of the excess heat caused by greenhouse gas emissions. This warming affects marine ecosystems, causing coral bleaching and shifts in fish populations. Another layer of evidence comes from satellite data, which allows us to monitor changes in land ice and glaciers globally. For instance, the Antarctic and Greenland ice sheets are losing mass at an accelerating pace, which is confirmed by multiple satellite missions. We also have evidence from the changing patterns of precipitation. Climate change has led to more intense and frequent heavy rainfall events in some regions, while causing more severe droughts in others. This shift affects agriculture, water resources, and even the frequency of wildfires. Moreover, we can examine the biological responses, for example, the timing of seasonal events like flowering. Absolutely. And all of these biological shifts combined with the physical and chemical changes in the environment paint a very comprehensive picture of how the climate is evolving. It's the convergence of all these lines of evidence, from direct measurements to natural proxies and observational data, that makes the case for ongoing climate change so compelling and robust. If you have any more questions or want to dive into any specific aspect even further, just let me know.
Okay, so my next question to you is why climate change is affect in our daily life?
That's a really important question. So, climate change impacts our daily lives in many direct and indirect ways. For example, rising temperatures can lead to more frequent and intense heat waves, which directly affect our comfort, health, and productivity. It can also increase the risk of heat-related illnesses, particularly for vulnerable groups like the elderly, children, and those with pre-existing health conditions. In terms of food, climate change can impact crop yields. Changes in temperature and precipitation patterns can lead to reduced agricultural productivity, affecting food supply and increasing food prices, which in turn can impact our diets and nutrition. Water resources are also affected. Changes in precipitation patterns can lead to droughts in some areas and flooding in others, impacting our access to clean water for drinking, agriculture, and industry. Additionally, climate change can affect our homes and infrastructure. More frequent extreme weather events like hurricanes, wildfires, and floods can damage buildings, disrupt communities, and lead to costly repairs and insurance claims. Health-wise, beyond heat-related illnesses, climate change can influence the spread of infectious diseases. For instance, warmer temperatures can expand the range of disease-carrying insects like mosquitoes, potentially increasing the incidence of diseases like malaria or dengue. Lastly, climate change can also impact our mental well-being. The stress of dealing with natural disasters, displacement, and the uncertainty of future climate impacts can contribute to anxiety and other mental health issues. In summary, climate change touches almost every aspect of our daily lives, and understanding these impacts helps us better adapt and mitigate the effects. If you'd like more details on Any specific area, just let me know.
Yes, more detail.
Of course, let's dive into more specific details. For instance, in terms of health impacts beyond heat related illnesses, climate change can influence air quality. For example, higher temperatures can increase the formation of ground level ozone, which can worsen respiratory conditions like asthma or bronchitis. This is especially impactful for children and the elderly. In terms of food security, climate change can lead to changes in growing seasons. For instance, crops that were once well suited to certain regions may struggle, leading to reduced yields. This can result in higher food prices and even food shortages, impacting nutrition and health. Water scarcity is another critical aspect. In regions prone to drought, climate change can exacerbate water shortages, impacting agriculture, drinking water availability, and even sanitation. From an economic perspective, climate change can affect industries like agriculture, fishing, and tourism. For example, reduced fish stocks due to warming oceans can impact the fishing industry, and extreme weather events can damage infrastructure, leading to costly repairs. On the social side, climate change can lead to displacement. Rising sea levels and extreme weather events can force communities to relocate, leading to social and economic challenges and sometimes even conflicts over resources. In terms of infrastructure, more intense storms and flooding can damage roads, bridges, and energy grids, disrupting daily life and economic activities. Lastly, on a psychological level, the awareness and experience of climate change can lead to climate anxiety and stress, impacting mental health and well-being. In essence, climate change weaves into nearly every aspect of our daily existence, and understanding these connections helps us better prepare and adapt. If there's any particular area you'd like to explore further, just let me know.
Okay, nice. So my next question to you is, how do ice cores probe climate shifts?
Great question. Ice cores are one of the most valuable tools for understanding past climate shifts. They're extracted from glaciers and ice sheets, primarily in regions like Antarctica, Greenland, and even some mountain glaciers. Here's how they work. First, when snow falls on a glacier, it gradually compresses into ice over time. Each layer of snow traps tiny air bubbles. As the snow compresses into ice, those trapped air bubbles become tiny time capsules, preserving a record of the atmosphere at the time the snow fell. By drilling deep into the ice and extracting these cores, scientists can analyze the trapped gases like carbon dioxide and methane to determine the composition of the atmosphere at different points in history. Moreover, the layers of ice themselves can tell us about past temperatures. For instance,
Okay, so my next question to you is, what role do glacier and polar ice caps play as climate indicator?
absolutely, glaciers and polar ice caps are crucial climate indicators because they essentially act as archives of Earth's climate history. For one, the extent and thickness of glaciers and ice caps can reflect changes in temperature over time. When temperatures rise, we see increased melting, and when temperatures are cooler, we see more accumulation of ice. Additionally, the ice cores extracted from these glaciers contain trapped gases and particles that help scientists reconstruct past atmospheric conditions, including greenhouse gas concentrations like carbon dioxide and methane. This allows us to track how the atmosphere and climate have changed over thousands or even millions of years. Moreover, the health of glaciers and ice caps today, whether they're advancing or retreating, gives us real-time data on the effects of modern climate change. For example, the rapid wilting of polar ice is a direct indicator of rising global temperatures. In summary, glaciers and polar ice caps serve as both historical records and real-time indicators of climate change, helping scientists understand both past climate variability and the ongoing impacts of human activity. If you'd like more detail on any specific aspect, just let me know.
Okay. So my next question to you is Chatgpt. Why climate change is uh, every year change, and why cause and what reason climate is change?
That's a great question. Climate change is essentially a long term shift in the average weather patterns over extended periods, typically decades to centuries. The reasons behind climate change are both natural and human induced. On the natural side, factors like volcanic eruptions can release large amounts of ash and gases into the atmosphere, temporarily cooling the earth. Solar variations like changes in the sun's energy output also play a role over long time scales. Additionally, natural cycles like the Milankovitch cycles involve periodic changes in Earth's orbit and tilt, which can influence climate over tens of thousands of years. On the human side, the primary driver of recent climate change is the emission of greenhouse gases, such as carbon dioxide and methane, from burning fossil fuels like coal, oil, and natural gas. Deforestation also contributes as trees that absorb carbon dioxide are removed. These human activities have led to an unprecedented increase in greenhouse gases, which trap heat in the atmosphere and cause global warming. In essence, climate change results from a complex interplay of natural processes and human influence, and understanding both aspects is key to addressing and mitigating its impacts. If you'd like to dive deeper into any specific part, just let me know.
Okay, nice. So this was our today ChatGPT. I hope you like it. See you another ChatGPT, another session. Till then, love is Pakistan. Jabad School, Painda.